Hello there, amazing people, students, lovers of chemistry, and subscribers out there. I am super excited to be here with you on this next episode on the concept of gas laws that we've been looking at for a while now. And today we want to look at the concept of the Boyle's law, which is one of the three major gas laws that we have. And by the way, my name is David, and all that we do here is to take the mystery out of chemistry so Chemi can make history. So let's see what the Boyle's law is all about. And let's also see if we can do justice to a few questions. Let's get into what we have for today's video. So first of all, the Boyle's law is a law among the three major gas laws that shows the relationship that occurs between pressure P and volume V of a gas when the temperature is kept constant. Alright, so now in our previous videos, we talked about some of the parameters that we measure when we're talking about the gaseous state of matter. We talked about volume, we talked about pressure, we talked about temperature. Now, one of the laws that concerns the gaseous state of matter is the Boyle's law. And the Boyle's law talks about the relationship that is occurring between pressure, P, and volume, V, when the temperature is kept constant. Now, what does that law state? The law states that for a fixed mass of an ideal gas that is kept at a constant temperature, the pressure is inversely proportional to its volume. How do we write that in math? If they say something is inversely proportional, we have the pressure P. It is inversely proportional to its volume. So that means P is inversely proportional to its volume. Inversely proportional will be written like this: 1 all over V. V here stands for volume, and then P here stands for pressure. What do we mean when we say pressure is inversely proportional to the volume? We simply mean that whatever happens to the pressure, the opposite will happen to the volume. So if pressure goes up, volume comes down. And if pressure comes down, it means that the volume will go up. So the key idea when we're dealing with the Boyle's law is that when temperature stays constant or stays the same, if pressure goes up, volume comes down. And if volume goes up, the pressure must come down. This is called an inverse relationship. Do we have any example to corroborate what we just said? Yes, and here are a few of them. The first one is the example of the balloon you have and you use at parties and in your everyday life. If you squeeze a balloon, what has happened? You have increased the pressure. You can see over here, this balloon is fully pumped and there is basically no pressure being applied to it from the external part of the environment. But in this case now, you can see that some pressure has been applied to this balloon by the squeezing force of this human hand. And in the process of squeezing it, the pressure has increased. And as the pressure increased, you can see the balloon becoming smaller, which means that the volume has decreased. So that's one application of the Boyle's law. In the process of squeezing the balloon, the pressure increased, and then that made the volume to decrease and the balloon got smaller. Here is another example of the Boyle's law being applied. The example of a syringe that is used in healthcare industries like clinics and hospitals. You see, when you pull the plunger, now here is the plunger of a syringe. This is the plunger, that part you pull when you want to suck in the liquid. When you pull the plunger, what happens is that the volume is increasing. And in the process of the volume increasing, the pressure inside the cylinder of the syringe begins to drop. And in the process of that pressure dropping, the liquid now begins to get sucked in. So that's the application of Boyle's law. If pressure increases, volume decreases. If pressure increases, then volume decreases. Here is one final example of the application of the Boyle's law. The air pump that we use in pumping our tires, our balloons, and our balls. When you push the pump down, if you push the pump down like this, it means that the volume of this pump will reduce, because basically you are pushing it down. So the amount of space for air inside this pump will reduce. And if the amount of space for air reduces, it means that the pressure will increase. Look at it over here. When you push down the pump, the volume reduces, and then it makes the pressure on the other hand to increase. That is why air is now pushed out because of that pressure into the ball or the tire or whatever it is that you want to pump. I trust you're following every step of what we're talking about in this video. If it's been educative for you, I'd like you to please do me a favor by liking, subscribing, and turning on the notification bell icon, so when more videos like this come out, you'd be the first to be notified. Now, here is the formula for the Boyle's law. It says P₁V₁ is equal to P₂V₂. How did we come about this formula? Where was it derived from? It was derived from the law that says that when a gas is kept at constant temperature, the pressure P is inversely proportional to the volume V. Now, look at this mathematical expression. We want to change this sign of proportionality into an equality sign. So to do that, we need to introduce a constant K. So when we introduce a constant K, this mathematical expression now becomes P is equal to K over V. So now that we have the mathematical equation, let's make K the subject of the formula. So to do that, we can simply cross multiply. When we cross multiply, it becomes PV is equal to K. What this means is that the product of pressure and the product of volume, pressure and volume together, will always be constant. So that means P₁V₁ will be equal to P₂V₂, will be equal to P₃V₃, and so on and so forth. So that's how we came about this formula for the Boyle's law. P1 stands for initial pressure, V1 stands for initial volume, P2 stands for final pressure, and V2 stands for final volume. Now, here is something you need to take note of, which is very important. You have to make sure that when dealing with gas laws, all the units match. So if you're measuring volume in, let's say, dm cube, it means V1 must be in dm cube and V2 must also be in dm cube. If you're measuring pressure, let's say in kilopascals, kPa, it means your P1 must be in kilopascals and then your P2 must also be in kilopascals. I'm sure you're following every concept that we're dishing out in this video. So now that we know that, let's see if we can handle some questions and do justice to them. So example number 1 says a gas has a volume of 4.0 liters and has a pressure of 2 atmospheres. What will be the volume if the pressure is increased to 4.0 atmospheres? Assume the temperature stays the same. So first things first, let's list out our variables and then impute them into the equation and get our answers. So they started off by saying a gas has a volume of 4.0 liters, which tells us that the V1 initial volume is equal to 4.0 liters and a pressure of 2.0 atmospheres. Initial pressure P1 is equal to 2.0 atm. Now they are asking us what will be the volume. What will be the volume tells us that the final volume V2 is not known. So that tells us that V2 is what we're being asked to look for in this question. So what will be the volume if the pressure is increased? P2 now becomes 4.0 atmosphere. So now that we have our variables, remember the Boyle's law states that P₁V₁ is equal to P₂V₂. So now what's our P1? 2.0 multiplied by V1, which is 4.0, is equal to P2 is 4.0 multiplied by V2, which is unknown. 2 multiplied by 4 gives us 8, and then 4 multiplied by V2 gives us 4V2. So in this case, we're looking for V2, which means we'll just divide both sides by the coefficient of V2, which is 4. 4 cancels 4 here. Then 8 divided by 4 gives us V2 is equal to 2, What is the unit we're going to use? Remember, V2 stands for volume, and for volume we're measuring it in liters, so we have V2 being 2 liters. So what does that tell us? The final volume now became 2 liters. So you can see the initial volume was 4 liters and the final volume was 2 liters, which tells us that the volume has reduced. Now, if volume reduces, let's check what happens to the pressure. The initial pressure was 2 atmospheres, but the final pressure was 4 atmospheres. So you can see that the pressure increased and then the volume decreased, which proves that the Boyle's law is actually applicable in this question. I'm sure you saw how everything was carried out. Let's see if we can solve yet another example. Now we have the next example that says a gas at 3 atmospheres has a volume of 2.5 liters. What will be the volume if the pressure is reduced to 1.5 atmospheres? So let's go ahead and see if we can do justice to this question. Listing out our variables, at first they said the gas has a pressure P1 of 3.0 atmospheres, then and a volume of 2.5 liters. So V1, which is the initial volume, is equal to 2.5 liters. What are they asking us? What will be the volume if the pressure, so V2 is unknown, if the pressure is reduced P2 to 1.5 atmosphere? So now, without even solving the question, we can notice that the pressure in this case has reduced because the initial pressure is 3 and the final pressure is 1.5. So that tells us that the pressure has reduced. So what does that tell us? If the pressure reduces, it means that the volume must increase. So let's impute the variables into our formula. P₁V₁ is equal to P₂V₂. So in this case, P1 is 3.0 multiplied by V1, which is 2.5. This is equal to P2, which is 1.5 multiplied by V2. So in this case now we have 3.0 multiplied by 2.5. 3.0 multiplied by 2.5 gives us 7.5, which is equal to 1.5 times V2. So to get V2, we just divide both sides by the coefficient, which is 1.5. So over here, 1.5 cancels 1.5. V2 is now equal to 7.5 divided by 1.5. 7.5 divided by 1.5 gives us 5 liters. So V2 is 5L. Now you can see the pressure reduced or decreased and the volume went from 2.5 to 5 liters, which tells us that the volume has increased. That tells us that the volume has increased. So you can see the Boyle's law being applied in 2 examples, showing that anything that happens to pressure, the opposite happens to the volume. So let's do a quick recap of all we've been saying since the commencement of this video. As far as the Boyle's law is concerned, when pressure goes up, volume comes down. And if pressure comes down, volume goes up. Temperature always stays the same. So that's it for the Boyle's law. But before we end this video, I'd like you to have some practice questions to try out your hands on, okay? So you can drop the answers that you get in the comment section and I'll be waiting to receive them. The first question says, if the volume of a gas is 6.0 liters at 1 atmosphere, what will be the volume at 3 atmospheres? The second question says, a gas at 5.0 liters and 2 atmospheres is compressed to 4 atmospheres. What is the new volume? So I'd be waiting to receive your answers in the comment section. Go ahead and do justice to those questions. So it's bye for now. I'm sure you enjoyed every bit of this exegesis on the concept of Boyle's law. I'd like you to go over it again. If there's anything you do not understand, please do well to reach out to me in the comment section, and I'd be willing, more than willing, to do justice to your confusion. Up until I come your way next time, my name is David, and all I do here is to take the mystery out of chemistry so chemi can make history. I'll surely see you in the next video.